All right, guys, we'll go ahead and cover lesson 1-2 today, which is over piecewise functions. We'll primarily look at these, from a graphing context using Desmos, but our learning target is I can evaluate piecewise functions. And I can graph a piecewise function with technology, that technology being the Desmos free graphing calculator that's online. We'll just jump right in. On example 1, it says, well, let's read the definition here. What is a piecewise function? Piecewise functions are functions that have multiple pieces or sections. They are defined piece by piece with various functions defining each interval. So like, for example, example 1, our pieces are defined by x plus 1. So like y equals x plus 1 and y equals 2x plus 7. And then we also have a given domain for each piece. Okay. So you can simply graph these very quickly using Desmos. We'll do one live here in a minute, but this one's already kind of graphed for us. So notice how it's all typed in there. We'll do something similar on the next example. Maybe instead of f of x equals x plus 1, you can just type y equals x plus 1. And then you put your domain restriction off to the right of it in brackets. Okay, so we use that piece when x is less than 2, and then so on. Okay. Anyways, if you type those in, we see the graph that you would get to the right. From there, we can just use that graph to evaluate where it wants me to. Okay, so one place it wants me to is where x equals -3. Okay, so just kind of looking at my graph, I can see that the function passes through the point. I know it's kind of hard to see on your paper, but you can just trust me that that is the point -3, -2. Where x is -3, f of x is -2. So this point right here shows me that f of -3 is -2. Okay, so we've done that part. They also want me to evaluate where x equals 2, it says, and where x equals 2, y equals 3. So because it goes through 2, 3, we can say f of 2 is equal to 3. And then finally, what's f of x where x equals 4? That would be right there. It goes through 4, -1. And again, that'll be easier once you're on Desmos. It's kind of hard to see the grid lines on the copy, but you can kind of see there, at least in that neighborhood. Is everybody with me so far? Does this kind of make sense? I think it'll make more sense once we do one all the way through. Okay. So no questions? All right. Let's work through number 2 together then, which is not graphed for us on our note template. So it says graph the piecewise function in Desmos and then evaluate f of x when x is -4, -2, and 0. So we want to find f of -4, -2, and 0. F of -2 and f of 0. All right, so let's do it. Okay, I'm gonna go ahead and pull up Desmos now and try to type in that piecewise function. So y equals 4x minus 2, where x is greater than or equal to -2, and y equals 2, where x is less than -2. Go ahead and pull up Desmos, and you can try to follow along or simply watch and take a mental note. Let's see. Got so many windows up. Try to see where my other window is here. I may have to new one. Do that. All right, so you can just type in Desmos, D-E-S-M-O-S. I have mine bookmarked there. So there it is. And we'll open the graphing calculator function. And let's type it in. Okay, so y equals 4x minus 2. Again, this is just the example from our note template. Our domain restriction, you want to type in brackets. So I just hit space once, and I'm going to open a bracket, and I'm going to type in my domain restriction for that piece. X is greater than or equal to, it says -2. So greater than or equal to, you can just, what I did was just type in greater than and then equal to, or you can find symbols down there on that keyboard if you're not familiar. I'm just going to hit enter and type in the other leg, which is y equals 2. And my domain restriction is in brackets again, where x is less than -2. Okay. So there they are, kind of on my screen there. I'm going to zoom out a little bit so I can see the bottom of this piece here. And I'm simply going to click around and see where my points are, right? So you can write these down as we go, but where x is -4 is like right here, okay? And I'm just going to click right there to see that y is 2. So it goes through -4, 2. And it'll stay there as long as I hold my mouse. Okay, so it goes through -4, 2, where x is -2 would be like right there. Now this one's kind of weird because it won't. I'm clicking, but it won't do anything here. That's because this piece right here is where x is strictly less than -2. So the one that's or equal to -2 would be the other piece. So I'd have to go down here to see that it's -2, -10. Okay, if you want to write down that point. Okay, if we were to graph these by hand, this endpoint here would be an open circle, and this would be like a closed circle. Okay, not that you need to know all that, but just trying to help you see the difference. And then it also goes through 0, -2, which is a little easier to find because it's the y-intercept, and it'll leave that highlighted for you. So those are my 3 points that we're going to take from Desmos. Anybody have any questions before I navigate away from this screen? All right. So again, we had our 3 points, which kind of basically help us to answer the question that f of -4 is 2, f of -2 is -10, and f of 0 is -2. Now, there is an algebraic approach you could take here if you wanted to, or you can just use Desmos, right? So I'm not going to do this for every one of these, but we could evaluate these algebraically as well. You might have thought about that. Maybe you didn't. Either way, it doesn't matter. But if I wanted to, say, evaluate this without a graph, here would kind of be my thought process. So f of -4, I would think first, you know, which domain restriction does that fit into? So that fits into less than -2, right? -4 is less than -2 from my options, right? And it says my rule is if x is less than -2, then basically y equals 2, right? Which matches up with our answer from okay. So you can do that as well. Okay, just one more example there. So if you know, if I wanted to evaluate this one without a graph, we already know it's -2, but I'll try to show you why algebraically. So 0 falls into the greater than or equal to -2 category, right? Where my rule is y is 4 times x minus 2, right? So that one we would say, okay, maybe we have to do the math. So f of 0 equals 4 times 0 minus 2, which is -2, right? So again, if you want to, you don't need to add all that. You don't really even need to know that, but I just wanted to show you could work these out by hand as well, okay? Does that kind of make sense? Everybody with me? Okay. All right. So we only have about 10 minutes before our drill. So let's go ahead and skip the try it for now and skip to the back. Let's do the word problem and kind of finish with that. All right, so our word problem here says your favorite dog groomer charges according to your dog's weight. If your dog is 15 pounds and under, the groomer charges 35. So let's go ahead and start to write our piecewise function now. So 15 pounds and under, we get charged $35. So we're going to say that piece is defined by this. F of x or y equals 35. If x is less than or equal to 15. Okay, that's how we would kind of formalize that as a piece of our function. All right, and then we say if it's between 15, so greater than 15 and up to and including 40, we get charged $40. Okay, so the way we're going to write that is $40 if. So here we have kind of two constraints. We haven't really seen this yet, but we write a compound inequality. Okay, so we put our low number here, 15 is less than x, or if we read that backwards, x is greater than 15, okay, and less than or equal to 40. So between 15 and 40, okay. We get charged $40, and then finally, it says, this part might get a little confusing, but if we're over 40 pounds, it says we get charged $40 plus $2 per pound for each pound over 40. Here's how you do that. So 40 plus $2 per pound. If I told you guys to try that on your own, most people would come up with this incorrect answer. You'd say 40 plus $2 per pound. So right line of thinking, but this doesn't work. Okay. So this would be like if we had a 60-pound dog, we would do, 60 times 2 would be $120 plus another 40. So we're getting ripped off there, right? So we didn't account for the above 40 thing. Here's how you do that. So erase that x if you were following along and replace it with a x minus 40 is how you account for those first 40 pounds, okay? So you could just leave it like that, or we can clean that up. I like it cleaned up, so I'm going to distribute and combine like terms there on that expression to get 2x minus 40. Okay, so that's going to be my last rule, 2 times x minus 40 if x is greater than 40. So there we have all our pieces kind of put together. All right, we've seen earlier how we could use Desmos here, and you could totally type all these into Desmos just for ease of well, we got to get done before the fire drill, right? So I'm going to go ahead and answer these just a little bit more quickly, kind of without Desmos. All right, so our follow-up questions. We skipped part A. But part B says, what are we going to get charged for a 10-pound dog? That would be 10 falls into this range. So we are going to get charged $35, right? So $35 for a 10-pound dog. What about a 25-pounder? 25 falls into this domain, right? So it says at this domain, we're going to get charged $40. So answer to part C would be 40. And then our 60-pound dog, 60 is above 40, so we're going to use this function rule right here. So 2 times x minus 40. So 2 times 60 minus 40 would be 80. So $80 for the big dog. All right, and again, the try it is very similar to this. If you guys want to tomorrow see the one we skipped, we can do that. But that is your lesson. There is no Alex assignment with this lesson. It's just a worksheet with similar examples. I'll tell you right now, I'm not going to put that in the grade book. So I would just say use it as needed. You will have a quiz question that's like this, so you may want to, actually do one or two and ask questions if you have any, but it's not going to be a graded assignment. So anyways, that's all I got. Thanks for listening.